Right, Jack, you can offload here. Alfred, take over, will you? Right.
Your house will crumble in 100 years. These structures will outlast human civilization itself. The difference? 20 construction methods so dangerous they were literally burned from history books. The third one seems physically impossible. Medieval builders figured out something in the 13th century that MIT scientists only confirmed in 2023. And honestly, it makes modern construction look a bit embarrassing. Here's the deal. When medieval masons mixed their lime mortar, they threw in chunks of unburned limestone. Seems sloppy, right? Like they couldn't be bothered to grind everything properly. Turns out those chunks were genius. When cracks form in the wall years later, rainwater seeps in and dissolves those limestone bits. The calcium-rich liquid fills the crack and hardens. The wall literally heals itself. No repair crew needed, no scaffolding, no guy named Dave charging you 70 pounds an hour. Modern Portland cement? Too rigid. It cracks more than the stuff it replaced. We traded self-healing walls for walls that need constant babysitting. York Minster Cathedral still uses traditional lime mortar for repairs. Why? Because every time someone tried modern cement on the 800-year-old stonework, it caused damage. The old recipe works better on the old building. Makes sense, right? But here's the catch that killed this technique. Lime mortar takes weeks to cure. Portland cement sets in hours. When money talks, patience walks right out the door. And now, building codes in most countries actually require Portland cement for structural work. The self-healing stuff is technically illegal. We banned the better product because it was slower. That pattern of abandoning superior medieval methods for faster modern alternatives, it shows up everywhere, including something even stranger they did with wooden pegs. Oak pegs might sound like ancient history, but here's the thing. They actually get stronger when it rains. Metal bolts, they rust. They expand. They crack the wood around them. But an oak peg, it swells when wet, gripping tighter than my uncle holding onto the last piece of pie at Thanksgiving. Medieval carpenters weren't just hammering pegs into holes either. They used something called drawbore joints. Sounds fancy, but the concept is beautifully simple. They drill the holes through two connecting timbers slightly offset from each other. When the peg went through, it physically pulled those timbers together. Permanently. No glue, no nails, no metal brackets. And the crazy part? Timber frame barns built in the 1300s are still standing solid today. Meanwhile, steel-bolted structures from the 1950s are falling apart and need constant repairs. That's a 600-year performance gap, folks. Guild masters knew exactly what they were doing. They didn't ban metal fasteners through laws. They banned them through knowledge passed down generation to generation. Iron destroys wood from the inside out. A single cathedral roof might contain 50,000 wooden pegs, each one hand-carved to match specific grain orientation. That level of craftsmanship takes years to learn. But modern building codes, they require metal connectors at every structural joint. The method that lasted centuries is now technically illegal. Makes you wonder what else we've outlawed in the name of progress. Speaking of materials we've banned, the next technique involves something you'd never expect inside a wall. Here's the thing about medieval builders that drove Victorian architects absolutely nuts. They were cheap, brilliantly, unapologetically cheap. Walk up to any castle or cathedral wall, and it looks like solid cut stone. Beautiful limestone blocks fitted together perfectly. But crack one open, total chaos inside. Random rocks, broken roof tiles, construction debris, basically whatever garbage was lying around the job site. The Tower of London, those intimidating walls are mostly rough chalk and flint rubble with a thin limestone veneer. It's the architectural equivalent of wearing a designer suit over your pajamas. And here's what kills me. Modern engineers assumed this was just medieval cost-cutting that somehow got lucky. Then they actually tested these walls. The rubble cores perform better during earthquakes than solid uniform walls. Why? All those irregular shapes create interlocking friction. When the ground shakes, the rubble pieces shift slightly, absorb the energy, then settle back. Solid walls can't do that. They resist, then crack catastrophically. Builders saved 60% on materials while accidentally creating earthquake-resistant structures. Or was it accidental? These were the same guys who built cathedrals standing 900 years later. The technique died because it requires masons who understand which rubble combinations work. Too much roundstone, wall collapses, wrong ratio of large to small pieces, unstable. It's like a recipe only master chefs can execute. Modern codes demand consistent materials throughout every wall, but consistency isn't the only thing they regulate. Wait until you hear what medieval builders added to their mortar. Here's where things get weird, and honestly, a little gross. Medieval builders added ox blood to their mortar, on purpose. Not as some dark ritual, though I wouldn't blame you for thinking that, but because it actually worked. The blood creates tiny air bubbles throughout the mix. Why does that matter? When water freezes inside mortar, it expands. Cracks form. Walls crumble. But those microscopic air pockets give the ice somewhere to go, room to expand without destroying everything around it. We call this air entraining today. Fancy term. We pay good money for synthetic chemicals that do exactly what pig blood did for free 700 years ago, and it gets better. Urine was on the ingredient list too. I know, I had the same reaction, but the ammonia in urine speeds up the curing process and increases early strength. German guild records from the medieval period actually specify 1 bucket of pig blood per barrel of lime. Written down. Official. These guys weren't messing around. The chemistry is solid. Laboratory tests confirm blood proteins work just like modern air entraining additives. The science backs up what looked like madness. Now, health regulations prohibit biological materials in construction products. Makes sense from a sanitation standpoint. Nobody wants to explain that ingredient list to building inspectors. The funny thing is, Chinese builders figured out the same principle using sticky rice instead of blood. Different culture, same chemistry, zero gross factor. Speaking of walls that move, the next technique sounds like a building inspector's nightmare. Intentionally crooked construction. Here's the thing about medieval builders. They didn't trust perfection. Sounds crazy, right? We spend millions on laser-guided surveying equipment to make walls perfectly straight. Medieval masons did the opposite on purpose. They built walls slightly curved inward from the start. Why? Because they knew every building settles outward over time. Stone compresses, foundations shift, wood shrinks, so they planned for it. The famous Tower of Pisa? Everyone thinks it's a mistake. Nope. Well, the lean was accidental, but here's what most people miss. The builders noticed the tilt during construction and actually made the upper floors taller on one side to compensate. They were correcting in real time, adapting as they went. Canterbury Cathedral takes this even further. The nave walls lean outward by up to 18 inches. 18 inches. A modern building inspector would have a heart attack, condemn the place, and probably need therapy afterward. But those walls have stood stable for 900 years, and that's the genius part. Medieval engineers understood that buildings aren't static objects. They breathe, they move, they settle differently depending on soil conditions, weather, even which side gets more sun. So instead of fighting against movement, they designed for it. Modern codes demand perfectly plumb walls, zero tolerance for deviation, which sounds smart until you realize we're forcing buildings to be rigid in a world that's constantly shifting beneath them. The medievals called this planned imperfection. We call it illegal. But speaking of things hidden inside walls, the next technique involves something completely invisible from the outside. The Great Fire of London in 1666 destroyed over 13,000 houses in 4 days. You'd think authorities would have studied which buildings survived and why. They didn't. They just banned all timber frames and called it a day. Here's what they missed. Wattle and daub walls, basically woven sticks covered in a mix of clay, straw, and yes, animal dung, had been protecting buildings for centuries. The daub doesn't burn. It chars. That charred layer actually insulates the wood underneath, buying precious minutes during a fire. Sometimes enough minutes to save everything. My grandfather used to say, "Don't fix what ain't broke." Medieval builders lived that philosophy. But there's another trick these walls pulled off that nobody appreciated until recently. They breathe. Moisture passes right through them, evaporating naturally on both sides. Modern insulated walls, they trap moisture inside. Then you get mold, then you get sick, then you spend thousands ripping everything out. Archaeological digs keep finding perfectly preserved daub fragments from buildings that burned down 700 years ago. The surrounding timber rotted completely. The clay mixture survived. Makes you wonder who really understood materials better. And the weird part is we've essentially outlawed this system. Current fire codes demand gypsum board, drywall to most of us. It scores well on paper tests, but creates moisture problems the medieval method simply avoided. We traded breathing walls for breathing problems. Still, wattle and daub need something solid underneath it. Turns out medieval builders had genius ideas about foundations too, including one that involved sheep. Here's the thing about medieval English builders. They had sheep everywhere. I mean everywhere. So naturally, they started stuffing wool under their foundations. Sounds crazy, right? Raw sheep wool packed beneath foundation stones created this perfect drainage and cushioning layer. The lanolin naturally repels water. The fibers compress evenly under massive weight. And those trapped air pockets? They insulate against frost, heaving in winter. Westminster Abbey reportedly sits on wool layers placed there in 1245. Still working. Now my grandfather raised sheep, spent my childhood surrounded by the stuff. Never once did I think this would make great foundation material. But medieval builders saw it differently. Wool was everywhere in England. The entire economy ran on it. Using it in construction was practical and patriotic at the same time. But here's what makes this genuinely brilliant. Modern foundations use concrete and gravel. Seems logical, except those materials actually transfer frost damage more readily than wool. When ground freezes and expands, concrete cracks. Gravel shifts. Wool just squishes a bit and springs back. Current building codes require those concrete and gravel foundations. No exceptions. You cannot legally build on wool cushioning today, even though it clearly worked for 800 years. The medieval solution was sitting right there in every pasture. No mixing required, no curing time, just pile it up and build on top. And speaking of unconventional surface treatments, what they did to their exterior stonework seems equally backwards. Until you understand the actual physics of water. Here's the thing nobody tells you about medieval stonework. Those old masons deliberately left their walls looking rough and unfinished. Not because they got lazy on a Friday afternoon, because they were smarter than we give them credit for. Smooth stone looks pretty. Everyone wants that polished finish. But water absolutely loves smooth surfaces. It clings to them, pools in microscopic pits, and slowly eats away at the material. A rough surface, water hits it and basically explodes into tiny droplets that blow away in the wind. The irregular texture also creates turbulent airflow across the wall. Sounds fancy, but it just means walls dry faster after a storm. Like how a crumpled paper towel absorbs better than a flat one. And here's where it gets painful. Victorian restorers looked at medieval cathedrals and thought they'd do everyone a favor. They smoothed out all that ugly, rough stonework, made it nice and pretty. Within decades, they'd accelerated erosion that the original builders had prevented for 400 years. Chartres Cathedral still shows the damage. Centuries of weathering? Fine. A few years of Victorian improvements? Disaster. Modern building standards demand smooth finish surfaces. We've literally outlawed the technique that kept these buildings standing. My grandfather used to say that some people are so busy making things look right that they forget to make them work right. The medieval masons understood something we've forgotten. Water follows smooth paths, but breaks apart on rough ones. But rough stone surfaces are nothing compared to what they were doing with chimneys. Medieval great halls had a chimney problem. Actually, let me rephrase that. They had a people kept dying from smoke inhalation problem. So they built chimneys wide enough for a grown man to climb inside. Sounds excessive, right? It wasn't. These massive flues could be inspected, cleaned, and repaired from the inside. No scaffolding needed, no tearing apart the wall. Just send someone up there with a brush. But here's where it gets clever. Medieval builders didn't just make one big tube. They stacked multiple flues inside a single chimney stack, and those separate channels created convection currents that basically suck smoke out of the building. Think of it like a vacuum cleaner for fireplace exhaust. Now compare that to modern chimneys. They're narrow, they meet minimum code requirements, and they build up creosote like nobody's business. You know that black tar stuff that causes chimney fires? Yeah, medieval designs avoided it entirely because the airflow never let residue accumulate. Oh, and castle chimneys often had another feature. Hidden chambers, some stored valuables, others served as emergency escape routes during sieges. Your chimney does what exactly? holds up a Christmas stocking, fire insurance companies in the 1800s started demanding smaller flues, cheaper to build, easier to inspect from outside, more profitable for everyone except homeowners dealing with constant maintenance. There's a chimney at Conwy Castle in Wales that still draws perfectly, 700 years old, zero mechanical assistance, zero modifications. Meanwhile, modern chimneys need annual cleaning or they'll burn your house down. But speaking of building methods we abandoned too quickly, here's the thing about modern lumber. We dry it in kilns until every drop of moisture is gone. Seems smart, except medieval carpenters did the exact opposite, and their buildings are still standing. They built with green wood, freshly cut, still wet, still alive, basically. Crazy, right? Well, here's why it worked. Green timber shrinks as it dries, about 10%, sometimes more. Medieval carpenters knew this. They counted on it. They'd cut joints slightly loose, assemble the whole frame, then wait. As the wood dried over months, those joints tightened like a vice grip. No nails needed. The building essentially locked itself together. I tried explaining this to a contractor friend once. He looked at me like I'd suggested building a house out of cheese, but the proof is everywhere. Westminster Hall's massive curved timbers, cut green and bent into shape while still flexible. 600 years later, they haven't budged. Meanwhile, my neighbor's deck from 2015 already needs replacing. Modern kiln-dried lumber does the reverse. It absorbs moisture from humid air, swells, then shrinks again. Every season, forever. Those expansion cycles gradually loosen every connection, and shipwrights use the same trick. Green oak hulls would seal their own seams as the wood dried and tightened. The boat literally waterproofed itself during its first year. Building codes now require kiln-dried lumber for everything structural. We traded a self-tightening system for one that loosens itself. Speaking of roofs, though, the medieval solution for keeping them waterproof was even stranger, and it was alive. Now here's something that would make your insurance agent have a heart attack. Medieval thatchers didn't fight moss growing on their roofs. They encouraged it on purpose, like putting out a welcome mat for the fuzzy green stuff everyone today power washes off their shingles. Why would anyone want moss on their roof? Because it worked like a natural sponge sitting on top of your house. When rain hit, the moss absorbed it slowly instead of letting water rush down and find every tiny gap in the thatch below. No sudden leaks, no dripping into the porridge, but that's not even the clever part. The moss layer added insulation value. Free insulation growing itself. Medieval homeowners basically had a living roof system 700 years before architects started charging premium prices for green roofs on modern buildings. And the bugs, oh, the bugs are brilliant. That moss ecosystem attracted insects that ate wood-boring beetles, built-in pest control that worked around the clock without anyone lifting a finger. A properly maintained thatched roof with its moss layer lasts 50 to 60 years. Modern asphalt shingles, 20 to 30 if you're lucky, we literally downgrade it. Fire codes and insurance companies effectively killed thatch in urban areas by the late 1800s. Fair enough for packed city streets, but even rural construction faces so many regulations that new thatched buildings are nearly impossible. English Heritage still maintains over 500 historic thatched buildings, using techniques that are illegal for any new construction. Speaking of things growing on medieval buildings, wait until you hear about what they did with spiral staircases. Castle builders were basically evil geniuses when it came to staircases. Every spiral staircase in a medieval castle winds clockwise as you go up. Sounds random. It wasn't. This gave right-handed defenders standing above a huge advantage. Their sword arm had full range of motion. Meanwhile, attackers climbing up, their right arm smashed against the central column with every swing. But here's where it gets devious. Those uneven step heights weren't sloppy craftsmanship. They were booby traps. Defenders memorized which steps were tall, which were short, where to place their feet in total darkness. Attackers stumbling into unfamiliar territory, they'd trip at the worst possible moment. I once visited a Scottish tower house and nearly face-planted on the third step, and I wasn't even being attacked. Now, some Scottish families built their stairs counterclockwise. Why? The Kerr clan was famously left-handed, generations of southpaws, so their castles gave the advantage to left-handed defenders instead. Your family's dominant hand literally shaped your architecture. The narrow central column created another problem for invaders. Only one attacker could engage at a time. The guy behind him was useless, just standing there watching his buddy get stabbed. Modern building codes demand uniform step heights and minimum stair widths. Safety regulations make sense for a shopping mall, absolutely destroy 700 years of defensive engineering. And the tight spiral wasn't just tactical. Each stone step wedged into the central column, supporting the one above it. Defense and structure in one elegant design. Speaking of structural genius, hidden in plain sight, you know how we build houses today? Walls hold up the roof. Simple. Medieval builders looked at that approach and said, why bother? Cruck frames threw out the rulebook entirely. Here's what they did. Find a massive oak tree with a natural curve. Split it straight down the middle. Now you've got two identical curved timbers that match perfectly like bookends. Stand them up, lean them together at the top, and boom. You've got a frame that carries the entire roof weight directly to the ground. The walls? Decorative. Seriously. You could knock them out tomorrow and the building wouldn't even notice. This is where it gets clever. That natural curve in the tree isn't a problem to work around. It's the whole point. See, wood grain follows the shape of the trunk as it grew. When you use curved timber, the grain flows along the bend instead of cutting across it. That makes it dramatically stronger than forcing a straight beam to do a curved job. Finding matching trees, though, that took patience my generation simply doesn't have. Builders would scout forests for years hunting perfect pairs. Try explaining that timeline to a modern project manager. And here's the kicker. Cruck buildings from the 1200s are still standing. The frame does everything while the walls just keep weather out. It's basically a permanent tent made of oak. Modern codes killed this completely. Walls must be load-bearing now, no exceptions. But speaking of medieval builders ignoring walls, wait until you see how they handled floors. Here's the thing about medieval floors. They weren't actually attached to anything. Sounds like a recipe for disaster, right? But those clay tiles floating on deep sand beds have outlasted pretty much every modern floor installation method we've invented since. The trick was simple. Instead of mortaring tiles directly to a concrete base like we do now, medieval craftsmen dumped several inches of fine sand and set the tiles loosely on top. Each tile could shift independently. If the building settled unevenly, which all buildings do, the floor just adjusted itself. No cracking, no popping tiles, no expensive repairs. And moisture? This is where it gets clever. Water vapor rises naturally through soil. In a modern floor with tiles mortared to concrete, that moisture gets trapped, creates mold, weakens adhesives, eventually destroys everything from underneath. The sandbed approach lets moisture migrate upward and evaporate naturally. The floor literally breathes. Winchester Cathedral still has 13th century floor tiles that look fantastic, 700 years old. Meanwhile, I've seen bathroom floors from the 1990s that look like an earthquake hit them. The practical benefit was absurd too. Damaged tile? A medieval worker could pop it out, replace it, and be done in minutes. Try that with thin-set mortar over concrete. You're looking at jackhammers, dust everywhere, and 3 days minimum. Current installation standards won't allow floating tile systems. Everything must be rigidly bonded. But rigidity creates its own problems. Problems that apparently need solving every 20 years instead of every 700. Speaking of things that shouldn't work but absolutely do, medieval walls had secrets buried inside them. Castle walls weren't just thick because medieval people liked exercise. Those 6 to 12 feet of solid stone served as the world's first passive climate control system. Here's how it works. Massive stone absorbs heat during the day, stores it like a giant battery, then releases it slowly at night. In summer, the process reverses. The stone stays cool while the sun bakes everything outside. Bodiam Castle maintains interior temperatures between 55 and 65 degrees Fahrenheit year-round. No furnace, no air conditioning, just really, really thick walls. Modern building codes push for thin walls stuffed with insulation. High R values look great on paper, but thin insulated walls react to every temperature swing outside. Your house basically has mood swings along with the weather. And the weird part is, energy studies show massive stone buildings use 40% less heating energy than code-compliant modern structures. We literally regulated ourselves into worse performance. I toured a renovated medieval tower last year. August. Brutal heat outside. Inside felt like walking into a refrigerator. No electricity involved. The walls were doing work that my home AC struggles to match. There's another benefit nobody talks about. Sound. Those thick walls create acoustic privacy that thin insulated walls simply cannot provide. Your neighbor's music collection stays their problem, not yours. Medieval builders couldn't explain thermal mass scientifically. They just noticed that thick stone buildings felt comfortable and thin wooden ones didn't. Sometimes observation beats calculation. But thermal mass only works if you can hold the building up. And medieval masons had hidden structural tricks above every door and window that we've completely forgotten about. Ever wondered why cathedral doors and windows from the 12th century are still perfectly intact while Victorian additions crumbled decades ago? The answer is hiding inside the walls. Literally, medieval masons were sneaky geniuses. They built secret arches above every door and window opening, completely hidden from view. The pretty stone lintel you see from outside, pure decoration, a facade. The real structural hero was an arch buried deep in the masonry, doing all the heavy lifting where nobody could see it. And the weird part is, this made perfect engineering sense. See, arches naturally redirect weight sideways and down. So when you stack thousands of pounds of stone above a window, the hidden arch channels that force around the opening instead of crushing straight through it. The lintel just sits there looking handsome. Modern steel lintels work completely differently. They concentrate all that stress right at their ends, creating failure points that medieval builders avoided entirely. X-ray surveys of old churches have revealed mind-blowing complexity. Some walls contain 3 or 4 overlapping arch systems, each one supporting different loads at different heights. Engineers scan these buildings expecting simple construction and find intricate networks that would make a modern architect jealous. Here's what kills me. We abandoned this technique because steel lintels cost less. That's it. Cheaper won the argument. Now we're paying the price with buildings that need constant structural repair. But speaking of hidden features doing unexpected jobs, wait until you hear what medieval builders did with unseasoned timber. They didn't just work around green wood. They weaponized it. Here's something that'll make your contractor cringe. Medieval builders grabbed freshly cut timber, still dripping with sap, and installed it as floor joists. On purpose, and they always placed it crown up, meaning the natural curve pointed toward the ceiling. Why? Because they knew that green wood would bow downward under the weight of people, furniture, and whatever else medieval life threw on those floors. The sag and the crown would cancel each other out. Perfectly flat floor. Try that logic on a modern building inspector. You'll get escorted off the job site, but here's where it gets clever. As that green timber dried over months, it shrank. And as it shrank, it locked itself into the mortise joints tighter than any metal hanger could hold it. The wood essentially welded itself into place through natural dehydration. Meanwhile, modern kiln-dried lumber, it starts perfectly straight, then develops a sag that only gets worse year after year. My grandfather's farmhouse had medieval-style joists. Still flat, my buddy's 10-year-old McMansion, the upstairs floor bounces like a trampoline. The guild system took this seriously too. Carpenters left marks on their joists tracking which forests produced timber that dried best for flooring. Basically medieval quality control, centuries before ISO certification existed. Building codes killed this technique. Everything must be kiln-dried now. Everything needs engineered metal connections. We traded centuries of proven performance for faster installation times. And speaking of things hidden inside medieval structures that nobody sees anymore, those fancy buttresses on cathedrals, they weren't just holding walls up. Flying buttresses look like stone arms reaching out from cathedrals. Beautiful, sure, but they weren't just decorative. They were the building's plumbing system. Medieval masons carved channels directly into these buttresses. Rainwater hitting the roof would flow through internal passages, traveling down through the stone structure and away from foundations. Clever, right? But here's what makes it genius. During heavy storms, all that water moving through the buttresses added weight, and that extra weight actually pushed harder against the walls, increasing stability exactly when the building needed it most. Think about that for a second. The rain that could damage the structure was actively helping hold it up. That's not just engineering, that's poetry in stone. Gothic cathedrals were essentially giant umbrellas. The roof collected water, the buttresses channeled it, and foundations stayed dry. 800 years later, some of these drainage channels still work perfectly. Notre Dame's buttresses, before the fire, contained functional medieval downspouts, still moving water like they did when knights were a thing. Then well-meaning restoration crews came along. They sealed these channels, filled them with mortar, fixed something that wasn't broken. Suddenly, water damage appeared in walls that had stayed dry for centuries. Modern engineers testing the original system found it moved water twice as fast as contemporary external downspouts. We literally went backwards. I find this hilarious and sad in equal measure. We built drainage technology in the 1200s that outperforms what we install today. Speaking of hidden features doing double duty, medieval doors had a secret trick too. Medieval blacksmiths figured out something about doors that we forgot, and then spent centuries reinventing with springs, hydraulics, and electronic closers. The trick? Mount the hinges slightly off-center. That's it. That's the whole genius. When you position the hinge pins at a precise angle, gravity does all the work. The door's own weight pulls it closed automatically. No springs wearing out, no hydraulic fluid leaking, no batteries dying at the worst possible moment. Castle doors using this method weighed 500 pounds or more. Massive oak slabs reinforced with iron. Yet they swung smoothly and closed themselves every single time. Zero maintenance required. Zero parts to replace. The hinge pins were positioned at angles calculated through generations of trial and error. Each blacksmith learned from his master, who learned from his master, going back centuries. They didn't have engineering degrees. They had something better. Accumulated wisdom that actually worked. So why don't we use this anymore? Modern accessibility codes require doors to stay open at any angle. Makes sense for wheelchairs and deliveries, but here's what kills me. We now install expensive automatic door closers to solve a problem medieval smiths already fixed with basic geometry. My local hardware store sells door closers for $80. That lasts maybe 10 years. Medieval castle doors using offset hinges lasted centuries. And speaking of solving problems the hard way when simple solutions existed all along, some medieval builders figured out how to construct massive stone ceilings without any temporary supports at all. And finally, the building trick that sounds physically impossible. Master masons built some stone vaults by cantilevering each ring of stones inward, one course at a time. No wooden scaffolding underneath, no temporary supports, just stone stacking on stone, each layer stable before the next one went up. How? Every single stone was cut so precisely that it locked into its neighbors through pure geometry. The weight of each new course actually stabilized the one below it. Work could continue through rain, snow, whatever. No waiting for carpenters to build elaborate wooden frameworks. Here's what kills me about this. King's College Chapel in Cambridge has fan vaults so complex that modern engineers have studied them for decades. Their conclusion? We cannot replicate them economically today. Not won't. Can't. Some medieval vaults contain zero mortar. None. They're held together entirely by stone geometry and gravity. 800 years of holding themselves up through math alone. So why don't we build like this anymore? Because the technique required 30 years of apprenticeship. You started as a teenager, and maybe you were trusted to design vaults by your 40s. Modern construction wants everything finished in months, not mastered over lifetimes. Also, trying this today would violate about 15 occupational safety regulations: fall protection, temporary bracing, insurance requirements. The paperwork alone would take longer than medieval apprenticeships. 20 band techniques, 20 solutions that worked for centuries. And the real genius? Medieval builders figured all this out without calculators, computers, or engineering degrees. Just observation, patience, and buildings that refused to fall down.